Okay, today we're going to have a look at the AH and K form of polynomial functions. And we're going to have a look at when the coefficient in front of x isn't 1. So within the power, x has a coefficient next to it. In order to be able to find AH and K, you need to be able to get this coefficient out. You need to be able to factorize it out from inside of the power and get it onto the outside, because we can only see AH and K when it's in the general form. And remember, the general form is y equals a x minus h to the power of n plus k. So the general form, inside the general form, inside that power, is x with a 1 as its coefficient. So let's have a look at this first example. We've got to remember that we're going to work within the power. That 2x plus 6 is all squared. So we have to think, how can I get that 2 out, but we've got to consider that power as well. So the first thing I do is I do a big set of square brackets and I put the power on the outside. That just jogs my memory that I'm still working within the power. So now I look at the 2x plus 6 and I'm working within the power. I factorize out the 2 and that leaves me x plus 3. Okay, so that's working within that power of 2. I haven't done anything with the power. All I've done is factorized within that power. Now, anything outside of the power is going to stay exactly the same. It hasn't changed. So the divided by 8 and plus 5 is going to be the same. Now, this is the tricky step. All we've got to remember is we've got a multiplication inside that power. So you've got 2 times x plus 3. Now that just brings us back to the index laws. When you have a times b all to the power of m, you can expand that power with a to the m, b to the m, because there's a multiplication within that bracket. Everything is either multiplying or dividing. So, to get rid of the 2, we're going to go 2 squared times by x plus 3 squared, all divided by 8 plus 5. So you got 4x plus 3 squared over 8 plus 5. And then you just factorize, cancel down whatever you can. X plus 3 squared over 2 plus 5. Now we have it in the AH and K form. There's no coefficient in front of the x within the power, ready to go. So the number that's multiplying the bracket is a half. A is a half. The dilation factor is a half. H equals negative 3. Remember, in the general form, it's x minus h. So if you've got a plus in that bracket, that means we've got a negative 3. Subtraction of a negative gives us the positive. And then we have k is equal to 5. Okay, let's try one more example. Same thing. We're going to look at a square root function. So the power's a half, but it's exactly the same thing. It's still an AH and K form. You've got a times by x minus h to some power plus k. So in this case, our power is just the power of a half. Everything else is exactly the same. So that 16 in front of the x here, that's all within the power. We've got to work within the power. So I go y equals, and I'm going to do the square root, and I'm going to keep everything inside of that power. I'm not going to touch that power. I'm working inside it. So I'm going to factorize out the 16, and I get that with x. Now, to figure out what's remaining here, I go 8 divided by 16. That leaves me a factor of 2, and then plus 2 on the outside of the square. Now, it's the same rule. A times by b to the power of m equals a to the m, b to the m. It's just that simple index rule. So the 16 gets the power of a half, the bracket gets the power of a half, and that 2 just stays on the outside. Square root of 16 is 4. Then we get left with x plus a half plus 2. Now we have an AHK form. There's no coefficient in front of the x. We're ready to go. So therefore, a equals 4. That's a dilation factor of 4. H equals negative a half. And k equals 2. I hope that helps you factorizing out the coefficients in front of x when we're dealing with the AH and K form. I'll do some more videos a bit later. Hopefully this is what you need. Let me know if you need any more help with this sort of stuff. Okay, see you soon.